Hello everyone. In this video, we are going to cover forces and its application. We are going to cover Newton's laws of motion and how do we apply those motion to for different scenarios. Okay, so let's start. So, what are the three Newton laws? The first Newton law is very simple. When there is no external force acting on an object, the object will remain stationary if it was stationary already, and if the object was moving, it will move with a constant speed. Second law says that the resultant force acting on the object is equal to mass times the acceleration of the object. And the third law says that for every force acting on the object due to some external source, there will be an equal and opposite force acting on the external source due to object. It means that if Earth is exerting gravitational force on me, so I am also exerting equal and opposite force on the Earth. Now we will learn exactly how to apply those Newton's laws of motion in different scenarios. So first we will look at this pulley based problem. Now let's say in this particular question, if mass m2 is greater than mass m1 and they are released from rest, the question is what will be their acceleration? Now in this particular question, we can see that since both objects are tied by one single string, they both will experience a same acceleration. So since m2 is greater, this will experience acceleration in downward, while this one experience acceleration in upward. For any forces related problem, we always recommend you to start with drawing free body diagram. So for m1, the forces acting is downwards weight, that is m1g, and upwards will be the tension acting. Now, since the acceleration is upwards, the tension must be greater than the downward force, and we can write Newton's second law. So Newton's second law says that the net force should be equal to mass times acceleration. But in this case, the net force will be the upward force tension minus the downward force m1g, and the mass is m1 times acceleration. So let this be equation 1. Similarly, I can apply for m2, which is accelerating downwards, so its weight must be greater than the upward tension. So in that case, if I again apply the Newton's second law, so I will get m2g minus the tension will be equal to mass m2 times. So you can see that this will be same tension acting because the tension is same and both the string is same. Now you can see that in equation 1 and 2, if we add equation 1 and 2, we can eliminate the tension because one, and what we will get is m2g minus m1g is equal to m2a plus m1a, which we can rearrange and rewrite as a is equal to m2 minus m1 whole g divided by m2 plus m1. So you can see that we have got a equation, a useful equation of acceleration. Okay, so the procedure here is always you start with free-body diagram, write a equation of motion, and then with the equation of the motions, that is net force is equal to mass time acceleration, we can create a answer. Now in this particular scenario, let's say if I want to figure out what's the acceleration here, this is, let's say, frictionless surface, and they are both accelerating in this direction. So if I want to figure out the acceleration in this case, in this scenario, what I will do again, I will draw a free body diagram. For mass m1, there is only two forces. So there is a normal force, and then there is a weight mg. But in a horizontal direction, there will be only tension that is acting in this particular form. Okay, and acceleration is in horizontal direction. So since there is no acceleration in vertical direction, I will take N is equal to mg, that is normal force are balancing out each other. But when I do net force is equal to mass time acceleration in the horizontal direction, only the tension force is there and the mass is capital M and there is acceleration. So let this be equation 1. Now, similarly, if I do it for the smaller mass M, there would be a smaller weight mg in the downward direction and the weight is upward. So this will be tension. Now you can see there is no horizontal forces. So if I do net force is equal to mass time acceleration for this. So net force will be, since it is moving downward, so I think mg minus tension is equal to mass times acceleration. So this will be equation 2. Now if we plug in uh, tension, if we plug the tension from equation 1 to equation 2, so substituting 1 in 2, what we can get is mg minus ma is equal to small n. And then we can move and rearrange terms to get a answer like this. Okay, so this is how we usually use net force is equal to mass time acceleration. So always the procedure starts with uh, using the net force question. Now, if we look at concept of friction, the friction is a force, another force which is a resistive force, which usually opposes the motion. It's always acts in opposite direction of motion if the object is moving, or the possible motion if the object is stationary, what possible direction it can move if the friction was not there. That is something that leads to two kind of forces, types of frictional forces, that is static frictional and dynamic friction. The friction force is always proportional to the normal force, or normal reaction force is basically a contact force which acts perpendicular to the point of contact, and these are related with the coefficient of friction. Static friction we use when the object is stationary, and dynamic friction we use when the object is moving. Now, static friction has a quality when that it increases with the applied force until it reaches a maximum value. When the applied force exceeds the maximum static friction, the object will start moving. The dynamic friction is when it is a constant force. So even if the applied force is increasing, the dynamic force does not increase. So we can plot this in a graph of friction versus applied force on the object. Let's say the block is sliding because of the applied force. So you can see that until it crosses the maximum static friction, the object will remain stationary. And then once it starts moving, then the dynamic friction is slightly lesser than the max static friction because of the inertia. Now we can see that we can apply this concept in this particular video. So, so first, what we will see is that a block of mass 2 kg is placed on a trolley of mass of 5 kg and moving horizontal. The force is 8 newtons is applied to the block which slides on the surface. The friction force between trolley and the ground is 0. So basically, if there is a friction force, the friction force between the trolley and the ground is 0, but friction force is not 0 from the block and the trolley. So the acceleration of the trolley is given. It is accelerating at 1 meter per second. What is the coefficient of friction between this block and trolley? So in this case, if you look at this question, for first approach should be always the drawing the free body diagram. So if I just take the block, if I take the block and I draw the forces, the force on the right hand side is the 8 Newton force. Okay. So now, if there is another force acting on this block, which is the friction force, also there is a normal force because of the contact, and then there will be weight of the block. The weight of the block is, so let for this question, let take G as 10. So weight of the block will be mass times G, so that is just 2 kg. So 2 into 10, so that is 20 newtons. Okay. Now we can see that the object is not moving in vertical direction, so I can take the normal force to be equal to mg, and I can get it. Normal force is 20 newtons. But in horizontal direction, the object is accelerating, which we don't know because we only know that the trolley is accelerating and the block is sliding on the surface of the slide. That's what they have mentioned in the question. So we can't take the acceleration of the trolley and the block to be same. So it can be different. Okay. But for this particular question, we don't need uh, the acceleration of the block. What we need is the coefficient of friction. Now we know that friction is equal to mu, that is coefficient of friction times the normal force. Okay, so here we can see that the one unknown thing about this is the friction. Now, since the acceleration of the trolley is given, now if I draw a free body diagram of trolley, there are two forces acting on the trolley. Now, yes, there will be vertical forces in terms of there will be a contact force from the ground and the contact force because of the block plus the weight of the trolley. Okay. But all those things, apart from all those things, there will be horizontal. So vertical forces will be balanced, but there will be horizontal force, and the horizontal force acting in this direction will be the same friction force which has this. Now, why this is same? This is same because this is Newton's third law. If the trolley is applying friction force on the block will be also applying equal and opposite friction force on the trolley. So this is that friction force. And we can see that that's the only force acting in a horizontal direction. So if I write net force is equal to ma in horizontal direction, then the net force is the friction force and the mass of the trolley is 5 kg, acceleration of the trolley is 1. So this friction is just 5 newtons. And if I plug this friction force in this particular equation, so I will get 5 newtons to be equal to mu times the normal force is 20 newtons. And we will get mu as pi over 20, which is 0.25, like this. You can see another example of such question. If the block M lies on the top of the mass M, then the trolley rolls freely, and there is a coefficient between the book and the table, and a person is pushing the trolley. What is the maximum acceleration of the table so that the book does not slide? Now, when here the book does not slide means what? The book isn't moving with the same acceleration as the trolley, and we can consider this as a horizontal force on block. So if I'm applying a table, like if I'm drawing the free body diagram of table have mass m, so it will have some weight. There is no friction uh, between the ground and the table. Okay, the box can move freely. Uh, so if I draw for the book first, so if I draw for the book, there will be a normal force and there will be a weight of the book, that is mg. Okay, now the book is also sliding. The book is sliding because there is a friction. There is a friction between the book. So I can take this the friction to be in this direction. Okay. Now there will be equal and opposite friction for the both of this friction because of Newton's third law. And you can see that this will be mg downwards, and plus there will be some normal force because of the book and from the normal force because of the ground. Now those vertical forces are balanced, so we are not worrying about vertical forces. The only thing that we need to know is this is mg, and the only force acting on the horizontal direction which is causing it the book for the book to accelerate, this is book and this is table, to accelerate is the friction force. So net force is equal to ma if I write, so friction force would be equal to mass time acceleration, and friction force can be written as mu times n, and I will get mu, that is a coefficient, n is mg. So acceleration will be same in both the cases. There is a forward force here. Okay. Yes. So acceleration from the book, equation from the book only, what we are getting is we can cancel out the m, and that will be equal to mu g. So that will be the same acceleration for both the table as well for the trolley, because they are not sliding. So in inclined plane problems, there are different versions of this. Now, in this particular version that I'm about to show, we are going to focus on a frictionless surface and the block sliding on it. So let's say we want to understand what will be the acceleration of the block. In that case, I will know that if the block is moving downwards, the acceleration will be in the downward direction. So if I want to resolve the vectors, so the forces will be acting on this block will be the weight of the block, and then there will be a normal force. Since this is a frictionless surface, there won't be a friction. And what we need to do is we need to resolve the forces. So here, the first step will be to resolve the forces along the direction of acceleration. So what I will do is, so instead of resolving this uh, normal force, I will resolve this weight along this direction. So along the acceleration, along the direction of the acceleration, this component, if this is theta, this component would be ws, w sine theta, and this component would be w cos theta. So you can see that in this direction, in the direction which is perpendicular to the plane, the forces are balanced. So if I do the net force is equal to mass time acceleration in y direction, in y direction. So I'm considering this is my y direction, this is my x direction. So in y direction, the net force will be 0. And the other forces are with Newton force, the normal force, and the weight, that is W cos theta. So I can write N is equal to W cos theta, where W is mg. So that is mg cos theta. So this is something that one equation we get in solving for y direction. Now in x direction, so we can say that the net force is equal to mass time acceleration. Now this time there will be some acceleration, and the only force acting in that direction is W sine theta. This one. So this will be W, and I can substitute mg, and what I will get is acceleration to be equal to g sine theta. So we can say that the acceleration, when the acceleration caused is not by the weight, but rather than the component of the weight along the direction of the plane. This is a component. Mg cos theta is component of the weight along the component of weight along direction of the plane. Now we can apply this to find if it is stationary. So if it is stationary, then there is something that is holding this block from sliding, and that is the friction force. So again, if I resolve those vectors, there will be weight in this direction, there will be a normal force in this direction, and then there will be a friction in this direction. Now this friction will be static friction, because the object is stationary. It means all the forces are balanced. So there is no acceleration in horizontal as well as in vertical direction. So I will consider again, this is my y and this is my x direction. Now you can see that in y direction, I first need to resolve the vectors first. So I will resolve this as w cos theta, and this will be my w sine theta, as this is my theta. So in y direction, if I use net force is equal to ma, since acceleration is 0, the other forces are balancing out each other. So this is my y direction. So n and w cos theta. While in x direction, I can say that this is n is equal to w cos theta. So n will be equal to mg cos theta. Let this be an equation. In x direction, if I apply again, since this is stationary, then the net force is equal to mass time acceleration. This will be zero, when the net force is w sine theta minus friction, and then it will give us friction to be equal to w sine theta, or friction to be equal to, I can write w instead of w, I can write mg sine theta. Now, usually we know that this is a static friction. So if there is a coefficient of friction along the surface, the coefficient of friction, let's say it is mu s, then we can write static friction to be equal to mu s times n. So mu s is the static friction between the block and the inclined plane. And if I know this, I can write static friction. I can substitute here. I will get mu s n to be equal to mg sine theta. And then I can substitute that n here, and I will get mu s mg cos theta is equal to mg sine theta, or I can write mu to be equal to tan theta. So this indicates what will be for a given coefficient of friction between the block and what is the max angle for which the block remains stationary. Because any angle that is beyond this angle, the block will start sliding. So that's the max angle. The block will remain stationary, and this is calculated by this equation. So if you know the coefficient of friction between the surfaces, you can calculate the angle, max angle. If the max angle is given, you can calculate the coefficient of friction by taking tan inverse of that. Okay. Now there is another situation where block is moving on a surface with having friction. So again, if I resolve the vectors, so this is my weight, this is my friction. Now let's say the block is sliding downwards. So this is the acceleration direction, and this is the normal. Now we will always resolve the forces. What's the approach? Free body diagram, resolve the forces along the direction of acceleration. So this is my x direction, this is my y direction. So I need to resolve this weight along these two components. So this will be w cos theta, because this is theta, and this is w sine theta. So I will say that in y direction, I will say that the net force is equal to 0, because the acceleration is not there in the y direction. So normal force and minus the weight cos theta, we will get the same result, that is mg cos theta. So that is same result. But in x direction, now there is acceleration. So what we will get is, when I choose net force is equal to ma. So net force in the x direction, in this direction particularly, w sine theta minus friction is equal to mass times acceleration. Now I can write this as mg sine theta, and friction I can write it as mu d, because now there will be a coefficient of dynamic friction, because the object is moving, so there will be a dynamic friction times the normal force. Now normal force can be written as this, so I can write mg sine theta minus coefficient of dynamic friction times mg cos theta. Now we can cancel out the m from this equation by dividing, and you can write this as g sine theta minus mu cos theta is equal to a. So we can find the acceleration by using this equation. So this is how we solve friction problems and the forces problems using net force equal. Thank you so much.